All right, here are solutions for perfect problem 6 for Math to 11. In this problem, you can do the same thing a bunch of times, or the same problem with a bunch of different methods. So you're going to add these two numbers together, and you're going to first use the standard algorithm. So you take this 1742, here's 1a, I guess, and you're going to add to that 1237. Like, that's easy enough, except remember that you're in base 8. So 2 plus 7, you might think of that as 9, but the way you should think about that is one group of 8 with one left over. And then you add 1 and 4 and 3, and you get 8 right here, which you should think of as one group of 8 with 0 left over. And you add in this column 7 and 2 is 9, and 1 more is 10, which you will think about as one group of 8 with 2 left over. And then 1, 2, 3, you get here. So what we get for our answer is this 3201, base 8. 1b, maybe I should be switching colors, but oh well, is similar. You're going to take 1742 and remember that you're in base 8 and add to that 1237, again in base 8. And now you're going to do the same calculations you just did, except instead of carrying numbers, you're going to write them all at once. So 7 plus 2, like we said, was 9, which you think of as one group of 8 with one left over. And then 40 plus 30 is 70. So you're just going to write 70 right here. And then 700 plus 200 is 900. But instead of writing 9, you're going to think about that as one group of 8 with one left over. And then 1 with 3 zeros after it, plus 1 with 3 zeros after it, gives you 2 with 3 zeros after it. So when you're doing the intermediate algorithm, you add like this, and now we add up these columns. 1 plus a bunch of zeros gives you a 1. 1 and 7 gives you an 8, which you write as a 0 with 1 carried over to this column. I don't know where you want to write it, right there maybe. 1 and 1 gives you 2. 1 and 2 gives you 3. So we get 3201 base 8, which was the same thing we got up here. And then the lattice method. For the lattice method for addition, you set it up very differently than the lattice method for multiplication. And so you kind of set up this grid here. And then you're going to add, so 2 plus 7, but instead of writing 1 down here and 1 up here, you're going to say 2 plus 7 is 9, which we write as 1, 1 if we're in base 8. So I'll write 1, 1. And then 3 plus 4 is 7, which we write as 0, 7 in base 8. And 7 plus 2 is 9, which again we write as 1, 1 in base 8. And then 1 plus 1 is 2, which we write as 2 in base 8. And then you're going to add along these diagonals. So I just get this 1 here. This 1 plus 7 gives me 8, which is a 0 and 1 carried up here. 1 plus 0 plus 1 gives me 2. 1 plus 2 gives me 3, and then I got 0. So I get 3201 base 8. Same answer that I got using the other methods. And then 2 says check your answer, which is kind of foolish at this point because you've already done it 3 times. You've kind of already checked it, but fine. Check your answer by subtracting 1742 from 3201. First, do the standard algorithm. So, okay, 2a. I'm going to start with 3201, and I'm going to subtract 1742. So to do this subtraction, I say, well, I can't take 2 away from 1, so I have to borrow, but there's nothing here to borrow from, so I come all the way over here. I cross this out. So instead of being 2, it's now a 1, and that changes this into an 8. Not into a 10, but an 8 because I'm in base 8. And now I have a number here that I can borrow from. So I take one of these away, so now it goes down to 7, and I get 8 more over here. So this moves up to what we would call a 9. You could also write that as 1, 1 if you want to stay strictly in base 8. But what I usually do is write it in base 10 for these intermediate steps. And then you can do your subtraction. 9 minus 2 is 7. 7 minus 4 is 3. 1 minus 7 can't do it, but I could borrow from this, which would make this a 9. And now 9 minus 7 I can do it, and 2 minus 1 I can do it. I get 1, 2, 3, 7, which is good. That's exactly what I was hoping to get. This is in base 8. And then finally 2b. 2b says that if you're trying to do 3201 minus 1742, what you can do is keep the top number the same, but then write the 7 complement of each of these digits here. So change it from a subtraction problem to an addition problem. And then the 7 complement. So the number that you'd have to add to each of these to make them 7. 1 would need 6 more to make it 7. 7 doesn't need any more to make it 7. 4 needs 3 more to make it 7. And 2 needs 5 more to make it 7. Instead of doing this subtraction problem, the 8's complement or 7's complement method would have you do this addition problem. So if you do this problem, 1 plus 5 is 6, 0 plus 3 is 3, 2 plus 0 is 2, 3 plus 6 is 9, which in base 8 I write as 1, 1. And then what I'm going to do is I'm going to take this first digit and I'm going to kind of add it over here to get 1, 2, 3, 7. So this is now gone and it gets added to this number, which makes it a 7. And then the 1, 2, 3 stay the same. And so what I get from my answer is this 1, 2, 3, 7, which is the same thing I got over here. I can check it off. Maybe I'll write it down here, 1, 2, 3, 7 after I do this addition, which goes up there. I think that's everything I had to do, so I guess that's the end of this video.